This question is on thermal property of matter, and you have a heating curve here, temperature against time, and you have a substance that starts from solid, all right, and it's heated with a heater of 2000 watts. So the graph is as given, and you're supposed to find the specific latent heat of fusion. Now, since this is a heating curve and here is fusion, so fusion is referring to the melting, the thermal energy that is being transferred into the substance during melting, okay, not boiling. All right, so let's put the states of the matter at the different stages of the heating process. So the first portion here, because it's a solid being heated, this will just be solid heating of the solid. When it starts here, then the melting process started, and that will be a combination of solid and liquid. Likewise, over here is fully melted, so here's liquid, and of course this will be liquid and gas, because during a change of state there's no change in temperature. So you should know that this is your melting process and this is your boiling process. Once you know all this basic, then we can go about looking for the specific latent heat of fusion, which in short is your LF. So we are assuming ideal situation where all the energy from the heater will be transferred to the substance. There's no heat loss to the surrounding. So I can actually start the equation by writing heat supplied by the heater is equals to the heat gain by the substance. All right, so I just write in short here. So the amount of energy that's provided by the heater, you have your power, which is your P, and you have your time that will give you the energy, E equals to PT. So over here, and for thermal property, of course, the Q here is also referring to energy. So over here on the left hand side, the heat supply, the energy supply will be power times time, and the heat gain during latent heat of fusion, we know that is actually referring to this portion over here. And the time is important to take note of the time here, and the time where the melting take place, okay, where the latent heat of fusion is being transferred into the substance is only for 150 seconds. All right, so on the other side here, that will be your MLF, the latent heat of fusion that's being transferred in. So the power is 2000, and as mentioned, the time taken for the melting process is only 150, and the mass of the solid is 2 kg times the LF, the specific latent heat of fusion that you're going to find. All right, if you work it out, your LF will be 150,000 joules per kg. And since the options are in terms of kilojoules per kg, so you're going to change it to 150 kilojoules per kg. So the answer will be C.